Right, good morning, Year 9. We're going to be doing some more work on similar shapes this week, but getting a little bit harder. Here's a starter question. There are 4 pairs of similar shapes. Can you work out the labelled lengths? Please press pause while you do so. Okay, so if I was doing this question, the first thing I would want to do is find the scale factor of enlargement on the first shape. I can see that a scale factor is 2. And that would mean that 20 divided by 2 is going to give me the value of x, which is 10. So I've got a 10 here. And 25 divided by 2 is going to give me y, which is 12.5. On my next pair of shapes, I can see that the length of 5 corresponds to 15. So I know the scale factor of enlargement is going to be 3. So if I'm working in the other direction, I can divide all of my lengths by 3. So I can see that y is going to equal 4, x is going to equal 4, and z is going to be 7. On pair of shapes C, I can see that 7, the side 7, corresponds to the side that is 21 centimetres on the enlarged shape, so I've got a scale factor of 3. I can therefore see that x would be 4 because I would want to make the larger length 3 times smaller, so x would be 4 centimetres. And if I'm looking at my last pair of shapes here, I always like the scale factor to be an enlargement, so where the smaller shape is being enlarged. So to get my scale factor, I would always do the larger length divided by the smaller length, looking at those corresponding sides. So the scale factor is 16 divided by 12, which is of course 8 divided by 6 or 4 divided by 3, so multiplied by 4 thirds. So therefore, if I'm going from side x to 12 centimetres, I therefore know that 4 thirds multiplied by x would give me 12. That would mean that 4 x's must be 36 if I'm multiplying both sides by 3 there. And then to get my final answer, I know that 36 divided by 4 is going to give me x. So I'm going to write down that x is 36 divided by 4, which is going to give me 9, and that's going to be 9 centimetres. I hope you got those ones right. Let's move on to question 2. Now in question 2, I've drawn 2 triangles here, and I've got certain symbols as the angles in those triangles, and I'd like you to think about whether you think those triangles are similar, and if they're similar, why are they similar? So if I have a look at those triangles, I can see that I've got 2 angles given. That must mean that the final angle is 180 subtract the 2 that I've been given. So I'm going to call the angle that's remaining in my first triangle star. But because I know that a star, a square and a triangle add up to 180, I also must therefore know that a star, a triangle and a square add up to 180 degrees as well. Now since my triangles have got the same corresponding angles, I therefore know that these triangles must be similar. So I'm going to say yes, they are similar because corresponding angles are the same or equal. So that's going to be my answer to that bit. Now, of course, in similar shapes, the angles that are corresponding are equal, but the sides are not equal because, of course, one is always an enlargement of the other. So the first thing I would like to do is find my scale factor of enlargement. And if I look at the side between the square and the triangle, those 2 sides must correspond to each other. So I'm going to do 14 divided by 8, which is 7 divided by 4, and I know that 7 quarters is 1.75 if I want to work as decimals. So 1.75 is my scale factor of enlargement. So therefore, to find side x, what I'd really like to do is I'd like to have a look at the side that runs between the square and the triangle. Now the side that runs between the square and the triangle is 6. So to find x, I know that that's going to be 6 centimetres multiplied by 1.75. And if I do that, I get 10.5 centimetres for x. Now the remaining side, which I'm going to do in a different colour, must be similar, must be corresponding to the side that runs between the triangle and the star. Or I should say the circle and the star, actually. So therefore, I know that y multiplied by 1.75 is going to give me 31.5. So to find y, I'm going to divide 31.5 by 1.75. And if I do that, it's going to give me 18 centimetres. So I have my two answers there. X was 10.5 and y was 18 centimetres. So I can always find the lengths that are missing when I have similar shapes, as long as I can work out the scale factor of enlargement. Now in my next question, question 3, it says the two triangles below are similar. Well, what two triangles are we talking about? Well, I can see triangle ABE, but I can also see a larger triangle, triangle ACD. If I were to sketch those separately with my black pen, I would be able to put some lengths on that would help me work out what the scale factor of enlargement is. So I'm going to write A, B, and E, and I'm going to put the lengths on that I've been given. So I've got 5 between A and E, and I've got a Y between B and E. And if I have a look at the larger triangle, I'm just sketching it, so it's not accurate, A, C to D. I can see that CD is 20 metres, but I can see that side A to D must be 45, add 5, which is 50. Now, because they've been taken from exactly the same triangle, I can see the angle at A must be the same in both triangles. So I'm going to colour that angle in blue. Now, what I can also see is that side BE and side CD are both vertical, which means that they must be parallel to each other. So my angle at AEB, whatever that angle is, it looks like a right angle because of course I've got a vertical line and a horizontal line meeting, must be the same as angle CDE because I have corresponding angles that run along parallel lines. And if I have a look at the final angle ABE, because I know that I have parallel lines, the angle must correspond to angle ACD. Therefore, I have similar triangles. So I'm going to pop those corresponding angles in to my triangles, even though they don't really look like right angles at the bottom, but it doesn't really matter. I know that they're definitely similar, because then I can work out my scale factor of enlargement. I can easily see that 5 times 10 is going to give me 50. And if I'm working backwards, I can divide by 10, and that would mean that y would be equal to 2 metres. So when I've got a triangle within another triangle, I draw them out separately, and I figure out they must be similar because their corresponding angles are equal, and therefore I can work out the scale factor and the length of any missing sides. I believe I've got one for you next. Okay, this is question 4. In the diagram below, side BE is parallel to side CD, and all the measurements are given. It wants you to calculate the length CD and also to calculate the perimeter of the trapezium EBCD. I'd like you to be able to work that out while you press pause. And now I'm going to go over this question. Now, I would never attempt a question like this unless I drew my two similar triangles out. So I've got triangle ABE, and I've got lengths 4.2, 6, and 4.8. And while I'm here, I'm going to make that common angle at the top red. And then the angle at ABE is going to be blue, and that means that angle corresponds to the angle at ACD. On the other side of my shape, let's get myself a different colour pen. Angle AEB B, I'm going to make a green angle, and that must correspond to angle ADC because I have similar triangles. So I'm now going to draw out my larger triangle. Very messy. I hope yours much neater than mine. I bet it is. And I've got corners of vertices A, C, D. And I'm just going to draw in those corresponding angles. And I like the way that everything is up the same way. So I haven't got any complications there. But one final thing I must do is I must write in any missing lengths. I can see that AD is 6 add 3, which is 9 meters. And I've got to make sure that I've found the length of CD. So I'm going to call length CD X. Now what I need to do is I need to figure out two corresponding sides in order to work out my scale factor of enlargement. So I can see that my scale factor is going to be 9 divided by 6. Now I know 9 divided by 6 is 3 over 2, which is 1.5 if you wish to work as a decimal, or we can work as fractions, it doesn't really matter, but I'm going to put multiplied by 1.5 there. Now to work out side CD, that means side X is going to be 4.8 multiplied by 1.5. So I'm going to do that. I get 7.2, I do believe. So X is 7.2 meters, which is length CD, which is what we were asked to do. Now I've now got to calculate the perimeter of the trapezium EBCD. So I can see that side CD is the one I've just found, which is 7.2 meters. But I've got one more problem, and the problem I need to work out is what length BC is going to be. Now I can't work out length BC until I've worked out the whole of length A to C. Now I need to work out the whole of length A to C, which is also on my larger triangle which I've drawn above. Now in order to work out length AC, all I've got to do is multiply 4.2 by 1.5. So I'm going to write down that length A to C is 4.2 multiplied by 1.5. And I'm going to get my calculator out to do that, and I do believe that's 6.3. So I'm going to write 6.3 on side AC. The thing is, I know that A to B is 4.2, so side BC is going to be 6.3, subtract 4.2. And I'm going to work that out. I've got 2.1. So I'm going to write B to C is 2.1. So finally, I can work out the perimeter of my trapezium. So my perimeter is going to be 4.8, add 3, add 7.2, add 2.1, and I'm going to end up with 17.1, and my units are meters. I hope you got that one right. Okay, moving on to the next question. Now, I've got quite a tricky question for you here. In the diagram below, I've got two triangles, ABC and DCE. You've got to explain why they are similar, and you've also got to find the missing lengths, X and Y. I'd like you to have a go first while you press pause, and then I'm going to go through it. Okay, now when I have two triangles drawn like this, I'm going to notice one really important fact, and a really important fact is the notation on side AB is an arrow and on side ED is an arrow, which means that those two lines there must be parallel. I also know when two lines cross, where they meet, I've got vertically opposite angles. So I'm going to say that angles A to CB must be the same as angle ECD because we have vertically opposite angles. To show two shapes are similar, I must show that all corresponding angles are the same. So therefore, because I know that sides AB and ED are parallel, I therefore know that angle A to B to C has got to be the same as angle C to E to D, because I have alternate angles. So angle ABC is the same as angle CED because I have alternate angles. And remember, they're the angle properties that we saw when we were looking at parallel lines. I've got one final angle. I've got angle BAC. Must be identical to angle CDE because, of course, we've got alternate angles again. So I've got angle BAC is the same as angle CDE because, again, we've got alternate angles. And therefore, what I can say is because I have angle, 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 corresponding angles, therefore we have similar triangles. Okay, part B, we've got to find the missing lengths x and y. Now this is a bit more tricky when you've got a diagram like this. And the trickiest thing is the triangles are not in the same orientation. So what we've got to do is we've got to make sure that we draw a separate diagram where the triangles are in the same orientation. So I'm going to be really careful about how I label these triangles. And I'm going to draw CED, which is my triangle on the bottom first. I've got my red angle up in the corner. I've got a blue angle at E. And I'm going to colour in my other angle, actually. I had it as black, but I'm going to make it as green, I think. So D is going to be a nice green angle there. So, getting my black pen, I'm going to write down my length. So side E to D is 5 centimetres, side E to C is 12 centimetres, and side C to D is Y centimetres. I'm now going to draw triangle ABC, but in a completely different way. I'm going to try and make it the same orientation as triangle CED. So I'm going to be very careful that my blue angle is on the bottom left-hand corner. My green angle is going to be on the bottom right-hand corner. And my red angle is going to be at the top here. Now I can see that vertex C is where the red angle is. And I can see that vertex A is where the green angle is, and vertex B is where the blue angle is. So now I can write my side lengths. A to B is 10 centimetres. Side A to C is 26 centimetres, and side B to C is X centimetres. And now I've got my corresponding sides. That means I can work out my scale factor of enlargement, and I can see that's nice and easy. That's 2. So now what I want to do is find out my other corresponding sides. So side X corresponds to side 12. That's great. So therefore I can work out side X because 12 times 2 is going to give me X, which is 24 centimetres. I can do something similar. I can say that Y multiplied by 2 is going to give me 26. So therefore, I'm going to divide 26 by 2 and Y must be 13 centimetres. It makes it much easier when you draw separate diagrams. So I'm going to give you one last question for you to have a go at. Okay, so in this diagram, all you've got to do is calculate the length of OB and OM. Try to draw 2 separate diagrams, figure out where the corresponding angles are, and press pause and have a go. Okay, so I'm going to go through this now. So I can see that I have the same angles when I have vertically opposite angles. So I'm going to colour in those angles there in red. Now, because I know that side AB and MN are parallel, I've got angle B to A to O must be the same as angle O to M to N because of alternate angles. And I'm now going to choose another colour. I'm going to have pink this time. So I've got angle A to B to O has got to be the same as MNO. And now I've done that, I can draw my separate diagrams. So I'm going to draw ABO and I'm going to draw NMO. Have to be quite careful here how I do this. So what I'm going to do is I'm going to make sure that I've got O at the top in both triangles, which means that I've got the red angle at the top in both triangles. I'm now going to make sure that I have the blue angle in one of the corners and the pink angle in the other corner. It doesn't really matter where you put them, as long as they're going to be corresponding to each other, so the triangles are in the same orientation. But now it really matters where the vertices are labelled. So in my first triangle, ABO, A is at a blue corner and B is at a pink corner. That means A to B is 3 and A to O is 4. On my other triangle, O is at the red angle, but M is at the blue angle and N is at the pink angle. MN is 6 and N to O is 7. I've got to find the length of OB, so I'm going to call that X, and I've also got to find the length of OM, and I'm going to call that Y. I can now see that I've got my sides in exactly the right places they should, because 3 corresponds to 6, and I can see that I've got a scale factor of 2. Therefore, that means that 2 lots of X is going to be 7, because of course the length where X is corresponds to the length where 7 is. So therefore I know that X is going to be 7 over 2, or 3.5 centimetres. In order to find Y, I'm looking at my other side that's corresponding. So I've got side OA, which is 4, corresponds to OM, which is Y. And therefore I know that 2 lots of 4 is the same as Y. Therefore Y is 8 centimetres. So with all those questions, they should prepare you for your 3 Hegarty tasks on finding the missing lengths of similar triangles. Good luck with your tasks. Please contact me if you need any help. Thanks very much. Good luck, everybody.